This is problem 2012 from question number 5. The rate at which the baby bird gains weight is proportional to the difference between its adult weight and its current weight. At time t equals 0, when the bird is first weighed, its weight is 20 grams. If b of t is the weight of the bird in grams at time t days after it is first weighed, then dB dt equals 1/5 times 100 minus b. Let y equal b of t be the solution to the differential equation above with the initial condition b of 0 equals 20. So we know we're going to use that initial condition somewhere. Is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? Explain your reasoning. So it's talking about it gaining weight, and it says that this is so that's a rate, and this is an equation of a rate. So all we're going to have to do for that one is plug in. So for when b equals 40, we do dB dt equals 1/5 times 100 minus 40, which would be 1/5 times 60, which equals 12. And then for b equals 70, dB dt equals 1/5 times 100 minus 70. We know that 100 minus 70 equals 30. So that equals 6. So it's asking about when the bird is gaining more or gaining weight faster, it's when it equals 40 grams. So you would say something along the lines to explain your reasoning of since 12 is greater than 6, the bird is gaining weight faster when it weighs 40 grams. Okay. That was part A. So for part B, it says find the second derivative in terms of B. Use the second derivative to explain why the graph of B cannot resemble the following graph. So I'm going to start by taking the second derivative of this. So it would be 1, the 1/5 is just going to hang out. The derivative of 100 is 0. The derivative of b, or negative b, would be negative dB dt. And I can substitute back in for the dB dt. So I'm going to plug that back in. So I've got negative 1/5 times 1/5 times 100 minus b. And if I simplified that a little bit, I'd have negative 1/25 times 100 minus b. So that's the first part of it. That's in terms of b. Find the second derivative in terms of b. It wants me now to explain why this can't resemble this graph that we have over here. And what this is saying is no matter what I put in for b, especially since the initial value is 20, and it has to be between 20 and 100 according to the graph. I know that this part in here is never going to go negative. So it's always going to be a positive times a negative, which means it will always be a negative answer, which means that it is concave down like a frown. So, and if you look at your graph, we have a portion where it's concave up and a portion where it's concave down. So it needs to be all concave down. So this part here isn't possible according to what we have. So we want to write that out. So therefore, the graph of B is concave down for the interval 20 to 100, and a portion of the given graph is concave up. All right, and then in part C, we're going to use separation of variables to find the particular solution. So here's where we're going to use that initial condition. So the very first thing, remember, we get lots of points for this part. This is a 5 points. But if we don't separate the variables, then we get no points on the whole thing, even if we get the answer right. So the first thing I need to do is move the dt over to the right side and take this and move it to the left side by dividing. So I've got 1 over 100 minus b db equals 1/5 dt. Now, on this particular one, next thing would be to integrate. So we've got our 1 point. We would need a U-substitution. So let's think about that. So U would be 100 minus B. Du equals negative dB dt. Or dB, yeah, negative dB, not dt. It's negative dB. I'm going to take that and I'm going to move that negative to the other side. So really what's missing is a negative. So I'm just going to add a negative out front. All right, when we integrate 1 over something, we know we get natural log of the absolute value of 100 minus b equals 1/5 t plus, and I'm going to go with a c sub 1 for now. I can always change it to c later. Now, again, since we know that this has to be between 20 and 100, we know that that's never going to be negative, so I'm going to drop my absolute value bars off of there. So I really have the natural log of 100 minus b equals 1/5 t plus c sub 1. Then at this point, I'm going to choose to go ahead and use my initial condition. I got a point for my antiderivatives and a point for my plus c. But now I'm going to plug that initial condition in to get my fourth point. So I'm going to put in 20 for the b. So I'd have negative natural log 100 minus 20 is 80. And then equals 1/5 times 0 plus c sub 1. So it's just going to be, c is just going to be the negative natural log of 80. So I'm going to plug that in. Doesn't look like I needed the c sub 1. I'm going to plug that into this equation here. Nope, sorry. This equation here without the... So I'd have a negative natural log of 100 minus b equals 1/5 t plus 80. Oh, plus, I'm sorry. Plus the negative natural log of 80. Then I'm going to exponentiate it. So I'm going to do e to the negative natural log of 100 minus b equals e to the 1/5 t minus the natural log of 80. Let me see if I can get myself some more space here. All right, I apologize for that. I'm going to put my work up a little bit higher. So I have to take this negative and move it up before I can exponentiate it completely. So I'm going to take, let me put my work up here. So we've got e to the natural log of 100 minus b to the negative 1 power. And on the other side, I'm going to go ahead and separate it. So I've got e to the 1/5 of t, e to the negative natural log of 80. Okay, so this is going to cancel. And I would probably cancel this as well. But my 80 is not where I want it to be. All right, I'm going to start from okay, let's take a look at part C. So we're supposed to use separation of variables to find the particular solution using that initial condition. So I'm going to start by moving my dt to the left and this to the right. Sorry, to the left and then the dt to the right. So we've got 1 over 100 minus b equal db equals 1/5 dt. I'm going to go ahead and integrate. I just earned a point for my separating the variables. I know that I would need a U-substitution, so U would be 100 minus B. So that means that du would be negative dB. So I'd get negative du equals dB. So really all I need to do is add a negative sign in there. So when I integrate, I get negative natural log absolute value of 100 minus B equals 1/5 t plus c. Then I know that because we locked out in part C or B that this in here has to be between 20 and 100, that these would always be positive. So I'm going to drop my absolute value bars. Plus B equals 1/5 t plus c. Actually, I'm going to go with c sub 1. Now, in order to get rid of that natural log, I would exponentiate it. Actually, what I'm going to do first is I'm going to divide that negative over to the other side, I think. Yeah, so let's get rid of that negative to the other side. So the natural log of 100 plus b equals negative 1/5 t. And still, if I divide by negative, it's still constant, so plus c sub 1. Now I'm going to exponentiate it. So e to the natural log of 100 plus b equals e to the negative 1/5 t plus c sub 1. These cancel. So I have 100 plus b equals, remember these we separate. So e to the negative 1/5 t, it says negative 1/5 t, e to the c sub 1. Then I've got 100 plus b equals this is just going to become another the constant. So I'm going to say C e to the negative 1/5 t. At this point, I'm going to use my initial condition. So my initial condition says I'm going to plop a 20 in there. So we get 100 plus, I turned mine minus into a plus, didn't I? These should all be minuses. Sorry about that. This is going to be a minus. So 100 minus 20 equals C e to the negative 1/5 times 0. Negative 1/5 times 0 is to the 0 power, and e to the 0 power is just 1, so that's going to go away. 100 minus 20 is 80, so C is 80. So we're going to go ahead and plug back in to this one right here. So 100 minus B equals 80 e to the negative 1/5 t. And typically on separation of variables, they like it solved for. So I'm going to take and I'm going to move the 100 over to the other side by subtracting it. So negative b equals negative 100 plus 80 e to the negative 1/5 t. Excuse me. And then we're going to switch our signs because we're going to divide by b, or divide by a negative. So that would be my final answer there. And they would probably write it as b of t equals.